Thanks. Thanks a lot. Yeah, it's really nice to be here. My second time in this amazing BOSC community, actually. I'm really glad to be here again. But today, actually, to present our work on lessons learned on improving the open data reusability of bioinformatics knowledge base. And actually, I'm co-leading the knowledge representation unit at the Swiss Institute of Bioinformatics. And yeah, I would like actually to start my talk by define an important keyword here. That's the keyword reusability under the scope of this work, actually. By reusability, we mean that the capability of a resource to be used multiple times by distinct agents. A resource here can be interpreted as a data, a workflow, tool, software tool in this case. All distinct agents could be an organization, a software agent, or a person. This definition actually is derived in a kind of an extension of one done by Akonen et al. In 92. Going more specifically about when you're talking about bioinformatics knowledge base, they're often built to serve a specific community of interest. For example, to define tools or methods and also provide data, of course. And for example, an example of a kind of a knowledge base is the BG knowledge base that contains multi-species gene expression information aggregated by different types of data. More general, when you're talking about applied computing, because bioinformatics is also part of applied computing, the relevance of data reusability by computer program has been highlighted since the past century, actually. But still, it's an old problem, but it's still up to date. And more recently, it was endorsed by the FAB principles, where you know that there are, most of you, I suppose, the R stands to reusability, more specifically for the reuse of research resources. In this work, actually, we looked for improving reusability through interoperability enhancement, actually, by enhancing interoperability. The finds that I will present here, the lessons learned, they were driven by several reward use cases that are mostly, some of them actually mostly were implemented by the BG knowledge base to further demonstrate in this work also when we're doing that they were transferable to other knowledge base. We also, when it was applicable, we show similar implementations by widely used bioinformatics database, knowledge base, such as GeneCards, UniProt, and orthologous matrix. But here, for the sake of time, I only concentrated in the use case involving the BG knowledge base. When you're doing this study, actually, we noticed that we could identify 3 different types of interoperability approaches. One of them we call one-side interoperability, is where one side must strictly comply with the other's procedures to interoperate with. There is no or little negotiation between interoperable parts. If you want to interoperate with that knowledge base, you really have to comply of the available procedures by them, actually. You cannot change much. Another kind of interoperability approach that gives you more flexibility, but it can take longer because there's the reconciliation aspect that both sides must reconcile with each other. That's established a common agreement to interoperate, actually. And finally, the multi-side interoperability is that you have 2 or more sides that wants to interoperate it and comply with an independent interoperability procedure, like, for example, data interoperability standard. To exemplify this different interoperability approach, I will show you some use cases involving the BG knowledge base. I will focus on 3 of them. This is like a subset of the interoperability network currently in place by with the BG knowledge base. And first, I will talk actually about the one between BG and Wikimedia projects. Secondly, with GeneCards, and thirdly, with Google data search tool, for example. One example of one-side interoperability is the one that's BG doing now between with actually Wikidata. Essentially, we have defined and implemented a bot that fetches the data from the BG database and makes it inserting available in Wikidata automatically when when we have a new release of the knowledge base. And the Wikidata is also interoperating with Wikipedia. We had to develop a submodel for the gene info box of each gene article in the Wikipedia that actually fetch the information available from the BG data source at Wikidata, and it's currently interpreting like that. But to do that, again, we have to comply with the interoperability procedures in place by Wikimedia projects. A second type of interoperability, it is the two-sided, as I mentioned, and to exemplify that, we have the BG with gene cards. To do that, we have to define a kind of a file-based data format for exchanging information. And currently, for each gene entering the gene cards, we also have the BG information available there. To exemplify multi-side, I think I already heard for past talks, I think also from yesterday, that they use schema.org as a kind of a data standard interoperability solution. For the BG use case, actually, not only the metadata about the data sets are available, but also the data by itself. We also have the expression, the gene expression calls described by using schema.org. And by doing that, actually, for the dataset part, it can be crawled by, for example, in this case, for the Google data search automatically, and the information will be available there. In parallel, actually, the good thing of this kind of approach is that once you do the work, it can be exploited, used by others, actually. Then you can promote data reusability, essentially. And for the case of ECCB, the Swiss Mathematical Resource Portal, they're also now implementing a way to crawl the schema.org from the different SIB knowledge bases, also to have this more automatically done. There's other tools that are available, like the Switch Data Navigator, that they will also be compliant with the schema.org. Here, I'm not going into details, but it's just to show that the interoperability is not, there is not like one size, like one solution fits all. Actually, then depending on the kind or on the target knowledge base, we have to adapt and so on, and there's different solutions for different use cases. Now, to start to talk actually about, in reality, the lessons learned. The first lesson learned actually is about, it's better to have some kind of extent of interoperability rather than none. The thing is that because to achieve a perfect interoperability, a full interoperability with a knowledge base, it's considerably hard for many aspects. Could be, for example, lack of resource, like human resource, lack of skills of some delegates between the knowledge base that could make possible the interoperability to be perfect and completely fully. And then instead of trying to do everything at once, it leads to the second lesson learned, that's better to improve over time. That's exactly this idea of iteratively improving the information exchange is better than trying to achieve full interoperability at once. That means that, why is that important? Because you have less information to exchange, you'll be less difficult, you facilitate the discussion with the delegates of the different knowledge base to make that interoperability possible. And another important reason of that is that once you establish some kind of extent of interoperability, partial, for example, the delegates of the different databases, actually, the knowledge base, they'll be more prone to improve it over time as well. The third lesson learned is about reusability, implies better visibility and vice versa. What we mean about that? Actually, once the data is reused by another knowledge base, it means that you also reach the community that's using that knowledge base. By doing that, even if they don't know which is the data source, but it means that in terms of data reuse, you're gonna get more users using it besides the knowledge base by itself. And there is another thing, that the fact that if you provide also some provenance and they agree with the delegates of the external database, the users of the community of the users can come back to the original data source and can also increase the number of users of your original data source, and consequently the data reuse as well, because they will discover all kind of information that's contained in your data, in your knowledge base. The fourth lesson is about interoperability requires maintenance. Most of the interoperability solution here involves software components. Then it's the same. For software life cycle, in terms of development, it requires maintenance. It also, if you want to improve, it requires maintenance. The fifth lesson learned is like automatize interoperability as much as possible. Why doing that? Because it can reduce significantly maintenance efforts by, for example, having the data up to date, providing real-time processing, like in this case, you're gonna have the latest information available immediately, depending on the degree of the automation that's it's done, and also depending on the degree, could also facilitate scalability. It means you can integrate easily another knowledge base. The 60th one is be flexible when choosing and providing some interoperability approach, because it not only for the delegates but the user of your resource, they don't necessarily have the same expertise. Then providing different ways to access the data, to use the data, and also to analyze the data is also really important, because we are going to have people that are like more they know, for example, a specific programming language like R, or know a specific query language like Sparkle, GraphQL, and so on. Then if you more options you have, you reach more and more users. And also knowledge base that can interoperate with you. Focus also on the knowledge base delegates. This is really important, mainly when you're establishing some two-sided interoperability approach, because there is no like magic solution or best technology or approach that will solve an interoperability problem if the delegates doesn't want to do the interoperation. Then it's really important to have a good work relation with the delegates. The 80th lesson actually is there's a positive effect of doing knowledge-based interoperability. One of the reasons of that is a kind of a transitivity by doing that. Like, for example, the example that I show for the Wikipedia projects, BG is interoperating with Wikidata, Wikidata is interoperating with Wikipedia, and by extent, BG is interoperating also with Wikipedia. It means that you make easier the work. There is another thing is that the fact that you provide that you have done one interoperability approach with some third-party knowledge base, possibly you could reuse it to do for other, because they will have maybe the same kind of way of interoperating, then you can reuse it as well. There is also an interesting here that specifically for the BG use case, since biocontainers is interoperating with bioconductor, there is an R package available of BG that was published in bioconductor. There's around like 15,000 downloads, and since biocontainers is interpreted bioconductor, now for the biocontainers, surprisingly, we have 300,000 downloads actually for the same package. Finally, there is these two lessons. That's to adopt the most appropriate license, also to avoid legal interoperability problems, and to focus actually more in the technical aspects and also the human aspects to perform interoperability. And finally, also provide documentation, training tutorials for interoperability. That's often seen as boring activities by knowledge-based delegates, but it's really important for promoting data reusability as well. Then to conclude, the best interoperability actually is the one that gets implemented. Despite the partial interoperability or dissent between knowledge representatives, either one or two or multi-site interoperability methods are all relevant to promote, at some extent, knowledge-based data use and reuse, etc. Providing also implementing one or more of these methods should not be considered as the final solution for interoperability, because the techniques evolve, the knowledge base also evolves. Then, in addition of apparition of new knowledge base, then it should be a continuous effort actually. And in the context of this work, also we provide some guidelines to pragmatic examples to how to interpret a variety of biological and general purpose knowledge base. And if you are more interested, we have like this is the preprint available, but you also appear soon at the Giga Science Journal. And I would also to acknowledge and thank you the BG team that's there and the co-authors highlighted in red. And then thank you very much. If you have any questions, feel free.
Thank you, Tarcisio. So does anyone have any questions? We still have about 5 minutes for Q&A.
Hi. Yeah, I have a long history with the internet back from the 72. And there was an immense amount of activity because everybody wanted to connect to everything for standards development. and technical working groups and all of that. And we had a thing called Interop where everybody would bring their computers and make sure they could work together. Is there anything that happens like that in the bioinformatics community, or is it all one-to-one kinds of deals?
I think I don't. Yeah, I mean, I would say that one of the examples, since I provided to be like the schema.org at some extent, because some initiatives comes to bioschemas, they succeed to be the schema.org. That's like a large community that's not only in bioinformatics. But yeah, I agree with you that there's a lot of work to be done in the sense that to have like more like a kind of, I would say, like agreement between different parts to avoid this kind of situations one-to-one. But it's another example of, I would say that it's tricky. It still is the case. It's like an old problem and it's still up to date, like as I said during the beginning of the presentation. Yeah.
Thank you, great presentation. I was wondering, in the specific case of academia, where many people are not on permanent position, the turnover of the staff can represent a challenge when it comes to maintaining particular standards or particular, let's say, practices. And you emphasize training, but I was wondering if you had other methods or strategies to ensure the continuity of the standards or conventions that you established.
Yeah, I think one way that I would say to avoid this kind of stuff is to go more into like a kind of like automatic interoperability approach that gives you more flexibility also in terms of maintenance, because you don't need, for example, to, depending on the approach you use, like a kind of like a data virtualization, you don't need to materialize things, and then you define, for example, mappings, and it's easier to maintain mappings than the data by itself. And it makes easier also for someone that you take over the work. And then I would say that one solution that to avoid this kind of thing, I mean, not necessarily to avoid, but to mitigate, it is to go to more like kind of automation in terms of interoperability, not doing this kind of like file-based, like a static modes of interoperability based on also, yeah, I would say in general, besides the fact of training, tutorials, available documentation, that's really important.
Thank you.